I'll begin again. Good morning to all, and welcome to this public meeting of the United States Consumer Product Safety Commission. We have two Commission agenda items today: a briefing on the National Academies of Sciences, Engineering, and Medicine's report entitled, quote, "A Class Approach to Hazard Assessment of Organohalogen Flame Retardants," end quote. And our second agenda item today is a CPSC staff briefing on general hazard scenarios associated with off-highway vehicle fires, burns, and debris penetration, as well as any recommendations CPSC staff may have for the applicable voluntary standards body. We will begin this morning our public hearing with a briefing on the National Academies Sciences, Engineering, and Medicine's report, again entitled "A Class Approach to Hazard Assessment of Organohalogen Flame Retardants." Briefing us this morning, and we extend a very warm welcome to Dr. David Dorman, who served as chair of the committee to develop a scoping plan to assess the hazards of organohalogen flame retardants. Dr. Dorman is a professor of toxicology in the Department of Molecular Biosciences of North Carolina State University. Dr. Dorman received his undergraduate training in chemistry at the University of San Diego and a Doctor of Veterinary Medicine from Colorado State University. He completed a combined PhD in veterinary toxicology residency program at the University of Illinois at Urbana-Champaign. He completed a postdoctoral fellowship in toxicology at the Chemical Industry Institute of Toxicology. He remained there as a staff scientist until joining NC State University Veterinary School as Associate Dean for Research and Graduate Studies. Dr. Dorman is a diplomat of both the American Board of Veterinary Toxicology and the American Board of Toxicology. Dr. Dorman's research interest includes neurotoxicology, nasal toxicology, pharmacokinetics, and cognition and olfaction in animals. He is an elected fellow of the Academy of Toxicological Sciences in the American Association for the Advancement of Sciences. He has served on advisory boards for the U.S. Navy, the National Aeronautics and Space Administration, the U.S. Department of Agriculture, and the National Toxicology Program, where he served as a member of the NTP's Board of Scientific Counselors. He has chaired or served on multiple National Academies committees, and he is a National Associate of the National Academies. His current National Academy service includes chairing the Committee on Toxicology and the Committee to develop a scoping plan to assess hazards of organohalogen flame retardants. And he is serving as a member of the Board on Environmental Studies and Toxicology. His past National Academy services includes chairing the Committee on Endocrine-Related Low-Dose Toxicity, the Committee on Predictive Toxicology Approaches for Military Assessments of Acute Exposures, the Committee on Design and Evaluation of Safer Chemical Substitutions, and the Committee on Potential Health Risks from Recurrent Lead. Exposure to DoD firing range personnel, and exposure to DoD firing range personnel. He recently served on the International Agency for Research on Cancer, Monographs Volume 123 group that evaluated the carcinogenicity of some nitrobenzenes and other industrial chemicals. Just reading that has exhausted me. So good morning, and just welcome to you, Dr. Dorman. We're so grateful that you came here this morning. Accompanying Dr. Dorman this morning is Dr. Ellen Mantis, NAS Project Manager, Ms. Susan Martell, Senior Program Officer for the Board on Environmental Studies and Toxicology, and Dr. Gregory Sims, Executive Director of the Division of Earth and Life Sciences. Again, I want to extend a warm welcome to all of you, and thank you for being here this morning and for all of the tremendous work that you all did on this report presented to the Commission. Following Dr. Dorman's presentation, we return to questions from the Commission. Each Commissioner will have 10 minutes each for questions, and we can go multiple rounds if necessary. And with that, Dr. Dorman, I would ask you to begin. Thank you.
Okay, thank you very much for that very kind introduction. I always joke with people, it's sad to hear your obituary while you're still alive, but thank you. And also on behalf of the committee and National Academies, thank you for the opportunity for me to provide a briefing on behalf of the committee. And so what I'd like to do is we did prepare some slides as briefing materials, and feel free to interrupt me at any time. I know you probably have some set rules, but if there's a point of clarification, feel free to interrupt me. I'm quite used to that. And so just to begin, one thing I do want to just remind everyone, especially maybe the public that might be watching this, is the role of the National Academies as an advisory group. And so one of the things to just consider is part of the reason why National Academy reports play such a critical role in what different federal agencies do is that they bring together a wide range of experts, but then these types of reports also go through one of the more robust peer review processes. So by the time a report like this one is actually published, there's been a lot of hands and eyes that have looked at that technical material and the conclusions that the committee draws. So hopefully I can advance the slides. So this is an abbreviated statement of tasks. So consensus study reports like the one that I'll be talking about today generally have a statement of tasks that outlines the scope of the project, the National Academy scope of the project that the committee is charged with. This is an abbreviation version of the statement of tasks, but it's the highlights. So one of the first things we were asked to do was
Excuse me, Dr. Dorman, I'm going to ask you just to move your microphone just a little bit closer. I'm hearing some feedback.
There was feedback here.
Yes, and maybe we can get Rock to check it out.
We'll try it.
Let's try that again.
Okay. And so there is a statement of tasks. So one of the first things our committee tried to do is to survey the literature to find out what chemicals actually constitute polyorganohalogen flame retardants. We also wanted to provide CPSC with one or more approaches in which a hazard assessment for a class of chemicals like the flame retardants could be performed. And then we wanted to give you a scoping plan that staff at CPSC could follow to try to actually implement the recommendations that are found in our report. So the committee, just like other consensus committees that I've served on, has a broad range of representation. There are members of the committee were drawn from academia, industry, and governmental laboratories. They also represent a broad range of scientific expertise, from my own expertise in veterinary toxicology. We had physicians with backgrounds in public health and epidemiology. We had several physical chemists. We had toxicologists. We had informaticists. So we have a wide range of talent that's on the committee that then is shepherded together to try to come up with the final work product. Then in addition to the committee members, we were also had two very excellent National Academy staff members, Susan Martell and Ellen Mantis, that also helped with the generation of the report and conduct. I'll also say that at different times our committee had input from CPSC early in the process, where we received briefings from your staff that was very helpful for us as we started to consider how we would tackle this project and be able to be responsive to the statement of task. So one of the questions that we were faced with was whether or not the large group of chemicals, and eventually we identified approximately 161 chemicals that would fit into this class, could actually be treated as a single class. And what you'll find is during the course of the briefing, and as you look at the report, we reached a very conclusion that said that as a single class of 161 chemicals, that we really couldn't deal with them as a single class for hazard assessment. So we would have to break them down into subclasses. So although we broke them down into subclasses, doesn't mean that we ended up avoiding a class-based approach. What it just meant was, rather than work with a large pool of chemicals, we broke it down into smaller pools, but a class-based approach still applies. And so really, as we go through this briefing, the traditional approaches used oftentimes by organizations is to do a chemical by chemical hazard assessment. So we do chemical A, come up with a hazard assessment, chemical B, keep going. In a class approach, what you're trying to do is find a group of chemicals that share different characteristics, in which once you start to study individual chemicals within that class, you extend that knowledge base to the entire class. And CPSC actually has experience with that with the phthalates, in which a class approach was used. So that in itself is not necessarily novel. So in the hazard assessment scoping plan that the committee came up with, we have three main elements. The first task is to actually identify and define what a class or subclasses are. And I'll take us through each of these steps. The next step, because we're doing a hazard assessment, and most traditional hazard assessments rely heavily on published literature, the next step in the process is to actually conduct a survey and then a scoping and survey of the literature. And then the third step is to actually do the formal hazard assessment based upon the evidence that you find from surveying the literature. So those are the three steps that get done in series. So in Plan 1, the first thing we do is try to identify the viability of a class approach. So the committee asked ourselves, in essence, can we take flame retardants and treat them as a single class? So one of the first questions we were faced with is, what are the flame retardants? So there's no really authoritative list that says these are the flame retardants. So what we did was, in our first exercise, is we tried to identify known flame retardants that are out in commerce. And so what we did was we basically looked at the literature, we drew from a number of different sources, and we compiled a list of chemicals. Then what we did is we tried to identify, were they all individual chemicals? Could they be mixtures? Could some of the chemicals actually be duplicates? Because sometimes you have chemicals that are the same chemical structure or named more than one way. So what we basically did was we annotated a list of chemicals that we refer to as the seed set of chemicals that we've identified as those chemicals that could be used as flame retardants. And what I kind of want to do is I'm going to step away from the chemistry for a moment and just talk for a second or two about taxonomy. So I think a lot of folks are used to the idea of animal classes. So being a veterinarian, I'm going to try to really kind of simplify what we did, okay? So as a veterinarian, from a taxonomy perspective, I might ask myself, what are cows? So what are cattle? So there could be features of cattle that we would want to identify them as a class. So what we would do is identify what do we think are classes of cattle, and we would start to identify what are those characteristics that that group of species of animals, that taxonomic group of cattle, share. Then what we'd want to know is there something distinctive about being a cattle? Is there something about being a cow that distinguishes it from being a giraffe or being an elephant or another animal in a taxonomy approach? In order to be able to do that comparison, what we have to do is compare it. So what we did as a committee is we took our seed set, and then what we did was we said all of these chemicals share a halogen. They contain bromine or chlorine or fluorine. And then we said, let's grab all the chemicals, all the animals that share those features. And then what we did was, in the next step, we then said, but that's a crude way, so let's refine it and ask, we're going to compare our seed set to other critters, basically, that share different properties. So those are our analogs. And then what we did was analyzed, is there a nature to being a cow, so to speak, distinct from all the other animals that we identified? And what we did was what we found was the seed set, when we compare it to analog structures, we couldn't clearly separate them. So in other words, they shared features that don't allow us to say this is a unique set of chemicals that have certain properties that allow us to distinguish it taxonomically from another group of chemicals. So that's in essence what this slide is trying to explain to you. So it's a very technical terms, and we used a lot of technical approaches, but at its heart, we grabbed a group of chemicals, expanded that list, and asked, could we separate them out? So once we came to that conclusion, that brought us to the conclusion that these are not a unique group of 161 chemicals that could be discriminated from other chemicals that share other similar features. So in order to do the next step in the analysis, what we did was broke down the ones used in commerce into 14 different subclasses. So we're still doing a class approach. But I found when I've talked about this report to colleagues, that kind of taxonomic approach hopefully helps you get through that portion of the report. So what we did was we broke the larger set of 161 chemicals down into 14 subclasses. The committee points out that the way they get broken down into subclasses, different groups might actually come up with a slightly different subclass approach, because we constrained our analysis in a couple ways. So what we said was, we don't want to have a subclass with just one member. So we didn't want to divide it and keep dividing and dividing and dividing it into smaller and smaller subclasses, because ultimately you'd end up with subclasses that really were not informing. So the 14 subclasses, every subclass had a small group of chemicals that shared certain physical chemical properties and or biological properties. So that's how the subclasses were created. So again, having it be subclasses, I think what the committee would encourage CPSC to do is not necessarily go through that same exercise. I think from a CPSC perspective, the 14 subclasses we created are a viable place to start with a hazard assessment for different subclasses of chemicals. And that we would also encourage CPSC to not more narrowly define them, because again, you end up having where you might have a subclass with, say, 2, and in a lot of ways, traditional approaches for subclasses of 1 or 2, you just would default back to a traditional approach. Okay, so that's in step 1. So we've completed step 1, we've created our subclasses. In step 2, what we would start to do is ask, what does the literature, what kind of data is out there? And so what we wanted to do is survey the literature. So what we did was we actually did a number of computer programs now exist that allow you to look at the literature that's published and be able to understand, is there data in EPA databases? Are there been other types of data available? Go.
I apologize.
Sure, no problem.
There is some concern that the hearing isn't being broadcasted online yet, and we just want to make sure before you go any further with your testimony.
Good luck. You can try. Because people right now, they're halfway through trying to figure out why I'm talking about cows, and that could be disturbing for them probably, right?
Okay, we've been assured that it's broadcasting, so you may proceed. Thank you so much.
Sure,
Dr.
no worries. And so the second big step is to try to survey the literature. And so in this initial survey, you're just trying to get a sense of, for a subclass, how much data is actually available. We're not trying to go to individual studies at this point. We're not trying to interrogate all the data. We're just trying to landscape it. Like, so is there a lot of data on certain chemicals, or is there like certain classes with virtually no toxicology data that's available in the public domain? And so when we're surveying the literature, you're just trying to get your kind of grips to what the data inputs might eventually be. And in our language within the committee report, surveying the literature goes beyond just peer-reviewed publications. So it may be technical reports you have access to. You're just trying to grab a lot of different types of data. You'll also notice from this slide that we're looking at different, what we refer to as evidence streams. So some of the evidence might come from human studies. Some of the evidence could come from traditional animal studies or other types of animal studies. Some might come from in vitro studies, mechanistic studies. So again, you're trying to grab all of this data at this point to just survey what's out there. So you then would want to map the literature. And we kind of didn't want to present some of the literature maps, but if you turn within the report, you can quickly see several figures that kind of show you what that mapping exercise will look like. So for example, I'll draw your attention to page 26 in the report, in which different horizontal lines represent different groups of chemicals, and then the vertical lines represent databases. And what you can quickly kind of appreciate is that just visually looking at this data, there's some classes where there's not a lot of bars. And not having bars means there's not a lot of data there. Okay. Other chemicals, what you might find is there may be 1 or 2 chemicals within a subclass that's actually data rich. And then others don't have any data. So again, why the survey becomes important is because it's now going to have down the road some implications about how do you kind of do this from a policy perspective? Because the science won't be robust for every chemical, so you're going to have to make some choices. Will we use, say, a data-rich chemical to draw inferences for a data-poor chemical? And we'll talk more about those scenarios here in a minute, but that's what this survey and map is actually trying to do in the report. So then in step 3, now you're going to do your deep dive. So what CPSC might choose to do is pick one or more of the different subclasses for a variety of different reasons. They may be the most important from a commerce perspective, however those decisions are made. But once you've made that decision to look at the deep dive for data, now what you're going to do is actually start to do a more rigorous look at the literature. So what you're going to do is actually search it, find the literature that's relevant to what you're trying to do, the hazard assessment, meeting the regulations that you're working off of, and then you'll extract that data. So you'll pull the data out of the primary literature and other literature sources, and then you'll have that data available so that you can start to make hazard assessment decisions. Again, you're trying to do this as a class, so you're simultaneously looking for data for, say, 10 members of a chemical class. So the survey, again, is just a broad understanding, the literature search, the deep dive. And there's a variety of different ways that a deep dive literature search could be performed. So for example, other Academy reports have mentioned things like narrative reviews or systematic reviews. So there's a growing literature base that says, here's how you systematically look for the literature. We didn't say, tell the CPSC that there was one method that had to be used. We were just recognizing that at this point, though, what ideally you would want to do is have a search that others could replicate. So if I was looking at how your staff did the search, I could understand what search terms did they use, what databases did they look at, so that I would have an idea of what was the scope of the actual literature search that was performed. So in a literature search, that can be very time consuming, can be actually quite an effort in and among itself in extracting lots of data. So sometimes what you would want to do is maybe make some decisions ahead of time that you're not going to try to search for every outcome that will focus on, say, cancer, because the survey indicates cancer may be the driver for that subclass, or it may be cancer and reproductive effects. So again, you're trying to have different steps in the process. You're having to make some expert opinions and make some expert judgments, then not just go as, and use everything. One of the other things we're recommending, and we'll talk about here in a few minutes, is that because there's a paucity of traditional data for a number of the classes and individual chemicals, you may need to rely increasingly on in vitro studies that have been performed for different chemicals. So you may have to make the move from traditional animal-based or human epidemiological-based studies to doing decision-making based on in vitro or non-traditional rodent or non-traditional animal tox data. So again, has policy implications, but that could be an important thing you'd want to do at this step. If you're not going to rely on that type of data, so you make the policy decision, we will not use this type of data to inform the hazard assessment, then quite honestly, you wouldn't go looking for it. But today, most of the guidance coming from national academies to different organizations is that type of data is going to become increasingly available. Traditional studies are less likely to be used, so most organizations are going to have to come with grips with how they'll use those types of data in the regulatory process. And we're encouraging CPSC to kind of become a leader in that area. So you extract the data. So again, this can be time intensive, and so you collect the data that you need, chemical information, biology information, what were the outcomes of interest. And then finally, what you have for a single subclass is you've brought together all the data you think is relevant for you to do the hazard assessment. At this step, you're doing the hazard assessment for a class of chemicals, not an individual chemical. And so what you're going to find is that we identified 3 possible outcomes for that class-based hazard assessment. you might decide that the data points to the class being hazardous. The data might point to the class being non-hazardous, and the data might be inconsistent, what we refer to as discordant data, in which it's not black or white to say it is or is not hazardous. What we found, just to forewarn you, what we found in our two case examples was discordant data. And if I had to predict, that won't be a rare outcome. It's not always going to be black and white. This subclass non-hazardous, this subclass hazardous. So we'll spend a few moments talking about how do we handle discordant data, because that's one of the outcomes that we identified in our scoping plan. So we tried to identify a few scenarios that your staff may be grappling with at the hazard assessment plan. And it's important for me to also point out the committee was not asked to actually perform a formal hazard assessment. So please be aware of that. Nowhere in our scoping plan was National Academies nor the committee asked to do a formal hazard assessment or risk assessment. So what we're trying to do in our report is illustrate likely outcomes. They're all data-based outcomes, they're all plausible outcomes, but it's not a formal hazard assessment. So I just want to make sure everyone, again, is reminded of that fact. So we were illustrating different scenarios. And so one scenario we mentioned in the report, for example, is you might have a really data-rich subclass. We've got, say, 10 members of that subclass, and 5 of them have been well studied. And a couple others have got some data. And all of the data for all of the members of that subclass are all pointing that there's a signal, a toxicity hazard from that subclass. They're all carcinogens. So let's say, hypothetically, of the 10 chemicals in the subclass, 5 are known carcinogens. And 5 have, say, data for mutagenicity that would make you suspect that they might also be carcinogens. In that scenario, that's a relatively straightforward scenario. You could treat that group as a hazardous subgroup and move on and make a determination. And in a lot of ways, that's kind of what you did with the phthalates. You kind of found a common mode of action, common chemical structure, and you said this is a group of chemicals that could be treated. The chap for phthalates kind of drew that conclusion. The other scenario, which I've already kind of alluded to, is that for some subclasses, you may not have a lot of data at all. So you've got a few choices. So one of the important things the committee wants to make sure that we communicate clearly is the absence of data should not be considered a subclass as safe. So we don't want to get into what we would refer to as an unfortunate situation where we do an unfortunate substitution, where we might take a compound that's somewhat hazardous, replace it with one where there was really no data at all. So if there's no data, we can't consider that to be non-hazardous. So that's an important caveat. So you may need to generate data. And so now here's where a few decisions have to come in. So do we generate data for traditional data for all the members of the subclass? That would be very time-consuming and expensive. Do we make some policy decisions that say we'll study a couple of animals or a couple of chemicals and then get traditional tox data for 1 or 2 members? And then what we'll do is extend that knowledge to the other members of the subclass. Or will we say survey using in vitro approaches that are less expensive? So there are several different scenarios here. Another possibility would be to say maybe we should just take that subclass and merge it with another subclass. So that would be another viable option. We might also use that broader set of chemicals we identified as analogs. Maybe there's a closely matched set of analogs that we can now use to inform it. But these are largely driven by some policy decisions as opposed to scientifically based decisions. They can be informed by the science, but they're largely different options that have some policy implications in them. So how would we generate data? Again, consistent with other National Academy reports, we would suggest a tiered approach to testing that from a cost effectiveness basis, you would want to start with lowest kind of systems, cheaper systems, in vitro test systems, non-traditional animal models like zebrafish and others, and then work your way up into more traditional testing as you deemed necessary. So the third scenario is where we have coherent data on a few members. And so again, you could make a decision that says, we're going to use, say, the most data-rich member of that group to drive the hazard assessment for the rest of the members. So again, that's a policy decision. That in essence, what we refer to in the report is those would be our anchor chemicals within a subclass. They're well studied. The other ones seem to be following in the same guise. And so what we can do is we would extend that knowledge to the rest of that subclass. And then the other option you would have is, again, there may be individual chemicals of interest because they're heavily used in commerce or other reasons where you might generate additional tox data for one or more members, additional members of the subclass. But here you have at least some data, and the data seems to be coherent. And the final scenario, which really was the one I think in a lot of ways our committee grappled with the longest because it's the one we identified in our two case examples, is you have discordant data. So you have positive results for one chemical in a subclass, negative results for the same endpoint for another member of the subclass. So that reaches kind of the broadest suite of different options that you might need to have to consider. So for example, what you might do is just say, conservatively, what we'll do is we'll treat the most toxic one in this subclass. We recognize they're not all behaving identically, but we'll recognize the most toxic member of the subclass, and we'll base the hazard assessment on that member. You might also decide that what you're going to do is you might have to actually parse that subclass into a few different, even smaller subclasses, because it may be that there's a common metabolite that some produce and some don't produce. So that's guided by expert judgment about why is it that half the group seems to be behaving this way, half the group is not behaving the same as the other fellows within that subclass. And then what you might do is some additional targeted analyses to try to elucidate why there's discordant data. And then, of course, you've always got the option of trying to generate new data. Okay. So as again, in the two case examples we had, we were faced with discordant data, but we tried to illustrate a couple of ways that CPSC might try to move forward in managing the discordant data. So a lot of what I'm mentioning is pretty time and resource intensive. And it requires some expertise that crosses a lot of different disciplines. But in a way of time and resource intensiveness, what we don't really recommend is going back to the traditional one chemical at a time approach. It's just too time consuming, too resource intensive. So coming up with policy decisions to help guide a class approach for your organization will expedite the process, it'll protect the public, and it'll cut down costs and it'll increase efficiency. But those are driven by some key policy decisions, and I can't stress that enough. And so you'll need to make decisions about, would you accept non-traditional tox data? That's a challenge not just for you, but for other organizations. I've chaired several committees now in which those have been recommendations to DOD and other organizations. So different federal partners you have are moving in that direction. And part of the reason for that is, again, cost, efficiency, and we've got a lot of chemicals out there with very, very little toxicology data. So it's one way for us to get some confidence or make some inferences. And then you'll need to make some decisions about what data, like minimal data set, would we need for a class approach. Because again, the traditional approaches we've always used for one chemical at a time, we kind of know the data we need. But now in a class approach, to have it all break down to just every individual chemical, we've got to do the exact same thing. It just isn't a viable approach anymore, as I'm sure you're well aware. So some concluding remarks that I want to just kind of bring back to your attention. So again, thank you for the opportunity to give you a briefing. Hopefully I haven't, disturbed you too much. I'm actually quite proud of the report on behalf of my committee members, and really thank National Academy staff. I think we tried to be as responsive as we could to your statement of task. I think in a lot of ways what we did was we tried to give you a blueprint, the scoping plan of what you might try to do. I know in discussions with my colleagues at Academies, Academies is here to help you in any way they can in the next steps. And I look forward to meeting with your staff here at lunchtime and throughout the rest of the day, but I think I'll be more than happy to take questions and try to maybe clarify points within the report that may not be as clear as I would hope they'd be at the end of my briefing. But thanks again for the opportunity.
Thank you very much, Dr. Dorman. We will now begin the commission's round of questions. Each commissioner will have 10 minutes to begin to have questions and ask questions of you and the panel. And I will begin the round of questions. I wanted to just go to the very basic premise in terms of, you talked about the traditional approach, chemical by chemical, and then I think essentially what was handed to us is you can't do the entire class of organohalogen flame retardants, so break it down into subclasses. Is there anything that's lost, or does it become less, I'll say, accurate or less informative by forfeiting the individual chemical by chemical versus, I think probably we are somewhere in the middle in terms of what you've suggested to us, sort of a compromise between this approach and the entire class approach. Do we lose anything? Do we gain anything? Could you speak to that a little bit and why that was chosen?
Right. So the breaking it up into the subclasses was science-based. So the committee really did try to treat it as a single group, but we couldn't do it from a biological perspective or a chemical perspective. It's just too diverse a group. So from a science defensible position, breaking them down into the different groups is a much more defensible scientific approach to do. And it's more in line with what others have thought about for a class approach for toxicology. What you probably lose is time and resources in some ways. If you had them as a single class, as a mega class that you could just make some policy decisions about, then that would obviate the need for breaking them down into the subclasses. But we didn't see that would be a non-science-based approach, that more policy to do that. But from a science-based perspective, breaking it down into the subclasses is more robust or defensible.
Thank you. I want to go now to, on one of your slides, the caveat of class approach to OFRs, and this is just probably what you just explained a little bit, maybe you could clarify. So the committee concluded that best approach is to define subclasses as broadly as is feasible. Is that, can you just speak to kind of what that term means?
So for us, what that meant was, again, when we were parsing these large class into subclasses, we constrained our thinking. So we said, we don't want a subclass with 2 chemicals. So we want subclasses large enough to make a class approach feasible. And so you could parse it lots and lots of different ways until you eventually come up with, in essence, 161 classes, each represented by an individual chemical. So our thinking was constrained to say, let's have a large enough data set that you could do it as a subclass, but not parse it till the end of time, so to speak.
Thank you.
But again, the parsing is based on, they all are sharing some chemical features. They're also sharing some biological activity or predicted biological activity. So it's not a random thing that these subclasses were created. The subclasses were based on the evidence we have about their chemistry, physical chemical properties, and predicted biological responses.
Thank you. I want to go to the no relevant data piece, and then so you gave us 3 scenarios. If you're saying that there's a class of chemicals and there's no relevant data relevant to that class, so you're giving these options. Am I understanding that correctly? Okay. And just because, and what I think you made very clear, is just because there is no relevant data, that does not mean there's not a hazard associated with the the flame retardant. Okay. So for option 2 or 3, I was curious, the reclassify the subclass so that data poor members are distributed in other rich data subclasses. Can you maybe elaborate on that a little bit? What does that mean? And again, do you lose anything in moving it to a different subclass?
Right, so we have a cautionary tale of, again, like you could get a different group of scientists together that might have did subclassifications in a slightly different way. So there's more than one way you could create your subclasses. What we don't think is a viable thing to do is every time you hit a headache, reclassify. Because then you're just changing the wheel and kind of kicking the can down the road, so to speak, for how you're going to do a class-based approach. So what we're recommending is that there may be times when you have to consider reclassification, but they should be done judiciously. And that's kind of the analogy, going back to my simple analogy, it's close enough to a cow that we're going to act like it's a cow type of analogy. So we're going to kind of, although it's ideally should be here, we're going to move it into another subclass, like next closest neighbor, so to speak, with those chemical properties or biological activity. But what we would not encourage you to do is just keep doing that endlessly, because that just will delay your analyses and will just kind of confuse and not have the transparency that we need.
Thank you. And then my last question for this round, I just want to talk a little bit about the discordant data. And so the options that you gave us, and I thought, and I just maybe you could elaborate a little bit on option 4, generate new data that could increase clarity and the scientific basis for the decision. Can you, to non-scientists, can you elaborate, what does it mean to generate? You just, because I thought an exhaustive, well, relatively exhaustive search had been done, so how would you generate new data?
So for example, I'll use a relatively straightforward point where we may have, say, a class of 10 chemicals. And so chemical A has been identified as a carcinogen. Chemical B in that subclass has gone through a cancer bioassay and has come out clean. It's negative, so it does not produce cancer. So that's an example of discordant data. They share certain chemical properties. So one thing you might ask is, what was the cancer driver, say a mutagenic effect? Did it affect DNA? And could we maybe look at other members of the class where mutagenicity data wasn't collected? Now we generate new data. If they're positive, we would treat them with the cancer positive one. And it may be that the non-cancer one we could explain for some other reason why it was negative in the bioassay. Maybe it got metabolized really rapidly, so we might need some pharmacokinetic studies. So that's where generating new data, where you've got discordant data, you could ask yourself, wait a second, there's like 3 members of the class are all acting the same, these 2 are not. Let's have some targeted studies that might explain that discrepancy. You could also come back to the different options and just say, let's not generate new data, we're just going to make a policy decision that says we're going to use those most toxic ones, for example, will drive the hazard assessment for the rest of the members of that class. So that would be another option.
Thank you very much. Commissioner Adler?
Let me begin by thanking you and the committee for the excellent work that you've done. I'm not a scientist, but there were great portions of it that I could understand and some portions that I couldn't understand. But I do think you and your colleagues have a reason to be very proud of the study that you've done, and I can't thank you enough for doing that. So I wanted to start with one question. We had a couple of days of hearings on organohalogen hazards, and one of the questions I kept asking, and I realize you didn't do a hazard assessment, but in those instances where you found it to be data-rich, did you find any of the organohalogens that you looked at and said, this is not a problem, this is not going to ever present a public health hazard, or anything that in effect would be exonerating one of these subclasses?
Right, so again, I'll come back to, we had a scoping plan, not a formal one, so the committee was never charged with that.
No, I understand.
So
I'm
it
just
would be-
asking if you or your colleagues...
So I'd have to
read-
say it'd be almost inappropriate for us to try
Okay.
to answer it in that guise, because we didn't do that type of
All right, well,
analysis.
I tried. So, and I thank you. And also, I also want to tell you how impressed I am with your understanding of the problems that we face as a regulatory agency. We're not a pure science research agency. We're a policy-driven agency where we're supposed to take the scientific judgments that you make and then apply them to policy, and I'm so glad that you understood that. So let me share one of the miseries that I think we face, which is we're a very, very poor and tiny agency, and I will only repeat this example one or more times. But when you look to see FDA's request for its budget last year, they asked for an increase. The increase that they asked for in their budget was about 5 to 6 times our total budget. And so I see the figures that you've given us in 8.5 years and $14.5 million. That should be easily addressed with other agencies for us. I'm not saying we couldn't do it, but it would be a strain. And so I guess one question I have is, do you have any suggestions to us if we were to undertake this or something similar, whether there are other bodies that could provide us or assist us in funding something like this, for example, EPA, if you've thought about that?
Well, we did. So I'll draw your attention, for example, to one of our committee members was John Booker, who at the
I
time
saw his name,
was
yes.
Associate Director of the NTP at that time. And so, for example, one of the things you can do is partner with agencies like NTP to develop the in vitro data that the committee talks about. That's part of why we highlighted, in some ways, the in vitro data, because there are federal programs going on in which chemicals get nominated and testing gets done. So there's a nomination process that you could work with NTP and other federal agencies to do that. I think the key thing, though, to really answer your question is you could be any of the federal agencies with all the money in the world, to be honest, and you were trying to then do a chemical by chemical approach traditional, you'd probably exhaust your resources trying to do that. So what we tried to be was pragmatic in giving you what I'll call policy outs. So make a policy decision on, say, precautionary principle. We'll do this type of thing. That's option 1, say, of just extend the most conservative estimate for hazard to the entire class. That those policy decisions, in essence, shortcut the need for all of the data. And they may still remain public health protective. And so we recognize that. That's part of why the committee actually put as much time and effort into trying to come up with policy choices for you, was trying to be pragmatic, just understanding you're going to be faced with these questions. And so what are those shortcuts that you might be able to take?
Well, 2 quick responses. First of all, when you say precautionary principle, I could see hair standing on end across the room, because that's one of those controversial approaches.
Using that strictly as an example.
No, I understand that, but you did mention Mr. Booker from NIEHS, and one of the things I did yesterday, just out of curiosity, I looked to see whether organohalogen flame retardants are a project with NTP. Apparently, they've never been nominated. So I guess my question, would it be appropriate for us, just in the interest of expanding the partners, to nominate OFRs to NTP?
Right. I mean, so this is kind of answering as Dave Dorman, not as the committee member.
That's fine.
But I'll answer in the guise that I was also on the Board of Scientific Counselors. So the Board of Scientific Counselors for NTP oftentimes gave feedback to NTP about which chemicals to pursue. So again, what you might find is that there's, say, a commercially viable or important subclass that has limited tox data. That would be a very appropriate thing to do, would be to nominate that chemical.
Thank you very much. And I just want to go back to a point you made, because it was also one of the points of contention in our earlier hearings. You have unabashedly, aggressively endorsed the idea of a class approach, and because otherwise we get into this doctrine known as regrettable substitution. So could I ask you just to speak a little bit more about why it's so critical that we adopt this class approach that you're recommending?
So the class approach has a couple of advantages. One is, once you start to make hazard calls for a subclass, if I, as say, a commercial manufacturer of a flame retardant, now bring into the marketplace a chemical that's very, very closely similar to the ones you've already made a hazard determination for, now your staff would be asking, does that next member, does it belong in that subclass? Whereas the current way, we would just be thinking about them as an individual chemical by individual chemical. And again, the CPSC, to your credit, when your chap looked at phthalates, that was part of the drivers, was trying to understand. Where this is different, the landscape's a little bit different than phthalates, is that the phthalates shared a common mode of action. And it was really kind of a data-rich set of chemicals, but still had its own challenges of trying to do a class approach. So that's one way that the public gets protected, is you can start to ask the question, is this next newest member similar enough to ones we've already made a determination of that we would say yes or no that it should enter commerce?
One of the things that instigated our attention to this was a petition that asked us to address organohalogen flame retardants in 4 product categories, which I won't run through, but I'm pretty sure you know what those categories are. But when I was reading your report, it dawned on me that you're not necessarily limiting your recommendations and your thoughts to just these 4 product categories. You're addressing organohalogen flame retardants as a broader class, and therefore would it be appropriate to say that any study that we would do, even if it were to be constrained or guided by the petition, would be in effect addressing hazards across the board with respect to organohalogens?
Correct. I mean, we took a broader approach. I'll also say that this may give you further guidance for other chemicals that are beyond the organohalogens. I mean, we were also very cognizant that we didn't want to create a scoping plan that would be one-off only for organohalogens. So although this plan deals with that current problem, you may be faced with similar concerns in the future with other classes of chemicals, and the scoping plan with some modification could be applied then more broadly.
Also, I would say that what your committee did, and excellently as far as I'm concerned, was a scientific analysis. I'm guessing you didn't have any lawyers on the committee. Is that fair to say?
So Appendix A provides the biographies, and to my knowledge, we did not.
Yeah, and it's not a criticism, but I did note that when you were in your report, you were talking about a proper approach to this, and one of which is you start with the finding of toxicity, and then you move to quantitative risk assessment. And the only point I would make is that we actually have a set of guidelines about addressing things like carcinogenicity, mutagenicity, teratogenicity. And quantitative risk assessment is certainly one of the tools, but it's not something that's mandated by our guidelines or by our statute. And so my question is, in terms of the scoping, did your scoping necessarily include the quantitative risk assessment? Was that a major part of the cost?
No, our scoping plan recognizes there's a follow-on step, but our scoping plan really is at the hazard assessment stage. Where the next step in the process, the risk characterization, could also come in, though, earlier, is when you're scoping the project. In other words, you may start to inform which subclasses you might want to study next, might be informed on, for example, exposure information that you have. So they're distinct, but some information may actually help guide some of your policy decisions. Some of that information may guide how you select a subclass for hazard identification.
My time is expiring, but I want to thank you for a very, very clear explanation, such that even I could understand it. So thank you.
Again, thanks for the opportunity.
Commissioner Kay?
Thank you, Madam Chair, and thank you to the panel for all the work. It really is a tremendous public service in a much-needed area, so we're deeply appreciative of what you've done. So a few questions about how we would potentially go forward and what work might already be going on out there. Are there other, mentioned NTP may not be doing OFR research, but is there other ongoing research that the committee is aware of that might help provide some of this new data?
So for example, I'll talk a little bit about just the zebrafish, because we highlighted that as one example. And again, I just want to illustrate that that was an illustration. We didn't say you have to use zebrafish. We just wanted to illustrate that as one data stream. And so we didn't try to scope all of the literature, but what we are is aware of that there are grants out there that are looking at comparatives. So you're going to be in a situation in which in the next 5-10 years, you'll have more data from academic and other labs where they're doing comparisons similar to the studies we've already reported. I mean, we were aware that some of those studies were on, but again, that wasn't a major focus for us. We were trying to look at what data is available now. In the arena of in vitro data, kind of non-traditional approaches, just knowing where the field of toxicology is going, and again, speaking as Dave Dorman, not on behalf of the committee, that type of data is going to be generated through, in academic labs largely over the next decade or so. So positioning yourself to be able to deal with that data and apply it to hazard assessment would be helpful for you as an organization.
Okay, so it's good to know. It sounds like even if we're not driving additional research, there is additional research that is going on. It may not be enough, but it at least continues to some extent.
And again, it's largely, because there's human exposures. So NIH is funding studies, there's human epidemiological studies, there's biomonitoring studies. So we allude to some of that. We point to, but some of those studies are long-term, where some of those cohorts of people will be reevaluated over time. So there'll be increasing data. The challenge you're again faced with is we tend to study what we know.
Yep.
And so there's a lot of the organohalogens where there's not a great deal of data. So those may continue to have paucity of data even in the near future.
I see. So that might be a role for us to maybe encourage some of that research.
Correct. Or again, like make decisions that say we'll live with our data-rich ones and have to extend it to the others.
And why does some, just out of curiosity, why do some OFRs end up driving data and some don't?
Could be because of human, I mean, again, we, as a committee, we didn't try to look at that background, but again, based on my own experience in dealing with a variety of different chemicals, a lot of that comes down to its broad use in commerce. So some of the chemicals are found in commerce more than others. And part of it also is they have positive signals. So toxicology, you tend to publish positive results, especially academic labs. So once you find a positive, you tend to get more positive studies because other labs are trying to replicate your results and things like that. So there's a little bit of that goes on as well. But
and then you mentioned new approach methodologies and the encouragement that we are open to that if we move forward from a time and resource standpoint. How novel would those approaches be relative to what EPA or NTP or other agencies are doing?
So I think where all of those federal agencies are kind of having to work hand in hand, trying to come up with a way to use those. So I think partnering with groups like NTP, FDA, EPA about how regulatory agencies are trying to use that type of information would be, you're at the forefront. I mean, if we go back to Academy reports advocating those, the use of non-traditional approaches, those have all been published in the last decade, so everyone is kind of moving in that same direction.
Got it. Okay, that's obviously something we can follow up with our staff. And then I just wanted to clarify something that Commissioner Adler said. I think many of us really do want to move away from a policy system where there is regrettable substitution, but I'm not hearing that moving to a class approach solves that problem. It just changes the basis of it. So it might be, instead of going regrettable substitution chemical by chemical, there's still the possibility of going regrettable substitution class or subclass by subclass, correct?
That's possible.
Okay. So this is, while this is certainly a better approach, this does not solve the ultimate problem of chemicals are put on the market without any assessment of what the effects are in humans, especially children. We have to wait usually decades to find out about the negative effects. And by the time somebody publicizes that and they're accepted, we move on to another chemical and repeat the cycle over and over again.
So I'll, again, draw on a little bit different experience, as was mentioned by Commissioner Burkle. I served on the chair of the committee that looked at the chemical alternatives of assessment. That was a project that was done through national academies, and that report was published a few years ago. One of the really, really important take-home messages was, again, the absence of data does not imply safety, does not imply no hazard. And so that's where many of the regrettable substitutions have occurred, is that we've got a well-studied chemical, we're concerned about it, so let's regulate it on that basis. Here's a second chemical that's out here that's available that could, say, replace that chemical in its application, but this one's not studied. So I think, again, what we would strongly encourage you is to really take all those steps not to do that type of a process. No data doesn't mean that there's no hazard.
Correct. We really appreciate it. Thank you again.
Okay.
Thank you. Commissioner Baiocco.
Thank you, Dr. Dorman. I appreciated your summary. I think I got it. And I do have some questions that I want to follow up. I took some notes, and I want to make sure that what I wrote down was correct. And thank all of you for the good work that you did. More to Commissioner Adler's point, the fact that the CPSC is a small agency and doesn't have the finances or the size that the FDA has does not relieve us of our obligation to make sure that we get to scientifically sound conclusions. We just need to do them in the most efficient and effective way possible, which is what I think I understood you're telling us by doing the class approach, and I just want to make sure that I got that right. And Commissioner Adler asked you a question about, you said it was why it was so critical to adopt a class approach. I don't remember you saying it was critical. What I understood is that what the committee did was give the CPSC a scientifically viable place to start, that there were the way you grouped the subclasses, there were some common, scientifically establishable common characteristics that we could go from there. Is that correct?
That's correct.
Okay.
That's correct.
So we don't need to do 161 different ones, but you gave us a starting point.
So again, what I would suggest is that the subclasses we formed was using strong science available now. It's been peer reviewed. And if your staff was charged with trying to do the hazard assessments for those subclasses, that'd be a very logical offshoot of this report and would be very defensible.
Okay. That helps. And I also wrote down here that I took away that you said by grouping the chemicals into the subclasses that you did, you gave us signals. So these are things that might also have the properties, but they're not conclusions. They're just signals from which to proceed, correct?
Correct.
And to address a point that all the other commissioners have raised, I also want to raise, because I think it's an important one, the no data doesn't mean it's safe, but it also doesn't mean it isn't safe, correct?
Correct.
We just don't know.
You just don't know. You don't know. So in the class approach that the committee is recommending, there may be policy decisions in which you sweep together compounds and make a hazard determination in which you actually didn't know. That is one of the outcomes that could occur.
When you say policy decisions, I translate that in my head to these are the margins of errors that we might be willing to accept. Can you tell me what you mean by policy decisions?
So what I mean is that there's so for example, let's say that a decision that's reached is, and I'll have my slide here say the first option, to extending the most conservative conclusion to all of the members of that subclass. That's not a science. The science helps identify which was the most sensitive ones, might identify the outcomes of concern, but the decision that we're now going to extend it to an entire subclass of chemicals, that's to us is a policy decision. It's informed by science, but it's not one that science on itself can make.
Okay, I think that's important. Thank you. And to just take that a little further, when you talked about having, we can use data-rich chemicals to draw inferences from data-poor chemicals, correct? We can draw inferences, but they're not necessarily conclusive, correct?
Correct.
And then we aren't able to draw those inferences any further than the basic inferences. In other words, we can't tell whether the basic inferences that are scientifically viable to draw from would actually be the same in different applications. In other words, if we put this chemical into a child's product that they mouthed, may be different than putting the same chemical into a casing of an electronic, correct? We're just talking about properties now.
So again, the hazard assessment is looking at the inherent toxicological potential of the compound. The scenario you're now talking about is the difference between the hazard and the exposure and the risk. And so, but the inherent hazard is independent of that application. The risk exposures can be widely different, but the
Okay,
hazard's
that
an
helps me.
inherent property.
So I think maybe what I was trying to get at was more of so you take a chemical, and when you have it interact with an individual, we could have just that. I mean, it's like having an addictive, we have a chemical that has addictive properties, but it doesn't mean that if I use that chemical or my colleagues use that chemical, we're all going to react, from an addiction point of view the same way, correct?
So as a toxicologist, I can't predict how any individual is going to react to the chemical, but the way a hazard assessment's done is what you're trying to do is look at the body of the evidence to make a determination as to whether or not that chemical has the potential to cause harm.
And then
Again,
at what level?
And at what level.
And
Correct.
then we get into the exposure, back to my example of child's products versus casing.
And individual variability. So for example, exposures to an adult may be something we handle, but an exposure to a developing fetus, you could have a very different outcome. So again, in a hazard assessment, what we're trying to do is identify what are those inherent properties of the chemical that could cause harm.
So that's where we are then. So what you gave us is a place to start. We still have to make those determinations that we just discussed, correct?
Correct.
Okay.
Correct.
And that parsing from here forward still requires, and those decisions still require a lot of expertise. Would you agree with that?
That's correct.
Okay.
That's correct.
Okay, so see, you did a great job. That's very helpful. I appreciate that.
And what I want to do is just spend one more moment about the expertise. The expertise is challenging in a couple of ways. One is that there's a lot of physical chemistry here. And again, I would not recommend you necessarily duplicate that wheel, okay? But where it also requires some expertise is just all of us trying to understand, and when I mean all of us, the toxicology community, of trying to move from analyzing traditional data to the less traditional data. So that's something, as a community, there's scientific expertise that's emerging in that arena as well.
Okay. That's all I have right now. Thank you so much.
Thank you.
Thank you. Commissioner Feldman?
Thank you, and thank you all for being here today. This has been an interesting discussion. And thanks, obviously, also to your colleagues over at the National Academies for their work in contributing to the study that you put forward. I had a question about the class approach, and then I also had a question about the hazard assessment scoping plan that you put forward. With the class approach that you've identified, taking a look at the subclass distinctions that are there, do those distinctions that are based on shared physical and biological properties of the chemicals themselves lend themselves to classification of future chemicals that may come into commerce? Are those core subclass properties the kind of chemical and biological markers that industry appears to be innovating around?
I can't speak to the innovation issue because that was, again, beyond the scope of our committee, but in answer to the first part of that question, yes. So what we're finding is that what we're stating in the subclass approach is that there's different functional groups that are in the chemistry, so that members within that subclass that all share that functionality. Oops. I can keep going in the dark. I mean, I'm a college professor, lights, no lights, awake or not, I can just keep going. So the issue really is those functional groups help drive the biology. So I'll use a simple example that is relatively straightforward. So for example, we can have compounds with a double bond. That double bond can get oxidized by the body, and in some circumstances can produce what's known as an epoxide. And what we know from those epoxides is those are very reactive molecules, and they tend to be mutagenic. And a number of carcinogens that share that double bond epoxide production can ultimately be carcinogens. Doesn't mean they all are, but it's a predictor. So now what you would do is if you've got, say, your subset that share that chemical feature, if now Dorman Industries is coming in and creating another chemical that shares that feature, then that would be, we would consider that to be a member of that subclass because it's being driven by that functionality, and it may also be hazardous just like the other members of that subclass. So that's a very kind of black and white example that toxicologists are very familiar with. In the case of the phthalates, that was, the orthophthalate type compounds. They shared a certain chemistry, they shared a certain biology. So the same idea.
Understanding that the R&D piece of this was a little outside of the scope of your inquiry, let me try to ask it another way. When you took a look at the 161 chemicals that sort of make up the universe that you were examining, that are the 161 chemicals that are in commerce, is that a universe that's been fairly stable over time, or are there new chemical entrants into that class?
Right. So
I'm trying to get a sense of how dynamic that field is.
So my guess is it's probably dynamic, and the reason I say that is for us, what we tried to do was we went to a variety of different sources to ask what had other groups identified as organohalogens. And what we actually found was there wasn't a lot of similarity between different sources. So source A may have identified 20 chemicals, source B 50 chemicals, and the overlap was actually fairly minimal. And so that, to me, it's indirect evidence, but that evidence would make me think that it's not necessarily stable as to what represents the organohalogen flame retardants.
Okay, thank you. With respect to the hazard assessment scoping plan, you talked about that for certain subclasses that you looked at and sort of previewed that this was likely something that we were going to encounter, that there are subclasses and will be subclasses where there's a paucity of traditional data, I think were your words, that put us in a situation where we're likely going to have to rely on in vitro versus other hazard assessment methodologies. Why would we want to use traditional data versus in vitro? Is there a risk in basing our inquiry on in vitro that we're going to miss something?
So you run the risk with traditional data as well. So there's, I'm a veterinary toxicologist. I've worked in the arena of public health for my entire career. The traditional models, they're an imperfect model as well. So part of it is asking, kind of going back to what level of uncertainty do we have? So it doesn't necessarily mean that a rodent bioassay is any more predictive than, say, an in vitro assay. We just have learned to accept it. We've accepted the uncertainties around using traditional approaches, and we're in a point in time in the toxicology scientific community where those similar kinds of assumptions will probably have to be made and applied to the in vitro data. Neither one is perfect.
And those are assumptions that are being made of necessity?
In many ways, yes. Yes. But they're also informed by the science. So it's not, it's an emerging field. We have some data. So, for example, the report talks a little bit about hepatotoxicity. So, for example, colleagues over in FDA have found that some of the in vitro assays are actually more predictive than rodents because some of the rodent models are so imperfect with respect to certain liver injury. So it's not, so part of it's out of necessity, but some of it is also based on a better, improved understanding of the biology. We have tools to interrogate biology today that we never had 20 years ago.
Okay. But those decisions then aren't solely based off of a cost savings associated with in vitro, and you may actually have in vitro studies that are more expensive than other ways of looking at the assessment.
That's entirely possible. What we do know is the in vitro assays are faster. Faster.
For
So,
those discordant subclasses, I mean, when you're looking at it and you get you're able to make a determination that the subclass is non-hazardous, that seems to validate the subclass decision and subclassification that you've made. When it comes back discordant, it would seem that there's then a drive to further segregate the subclass into sub-subclasses.
So that's one of several options.
Is there a risk that in taking a look at a discordant subclass where you're seeing certain chemicals in the subclass behave a certain way and other chemicals behave another way, that's going to call into question the overall thoughts and assumptions that went into making that subclassification determination in the first place?
So we do recognize that could be iterative. In other words, the sub-classifications right now are based on an underlying assumption that these physical properties or chemical groups within the chemistry and what we think are predictive biology were all used to inform that subclass. And so then in science, we sometimes make mistakes. So it is possible that data may be found in which the assumptions of predicted biology actually turned out to be a fallacy. So that's an outcome that could occur.
Okay, and there could become a point where you sort of made those further distinctions to the point where perhaps the correct course of action is to just begin taking a look at individual chemicals.
You may end up having to default to that. It's just, again, that's an approach you're already very familiar with, but again, we were charged with giving you guidance for a class-based approach.
I understand. I'm running low on time, but I would want to open this up to the rest of the panel who've sat there very diligently throughout the briefing today. Dr. Dorman, do you or anyone else in the panel, are there any other broad takeaways that haven't been raised that the Commission needs to be paying attention to based on the research here?
No, but I'll turn it over to my colleague at National Academies. He may want to talk about next steps for academies.
Please.
Yeah, thanks, Dave. Yeah, we don't have, as Dave mentioned before, the academies stand ready to help in any way we can. We don't have a specific proposal, but in terms of next steps, we will be continuing the conversations with your staff, and one way is just to, we can bring in Dave back and other members of the committee back just to, there are a lot of details in the report itself, and would be happy to continue the conversations and come back and talk to you further if you have further questions. But I think that's the natural next step, and explore options. And if there is more targeted, kinds of interactions that we can take place over weeks or months, as well as more, if you get to a point where you do need another formal consensus study at the, similar or to the one that we already carried out, we can talk about that as well.
I appreciate that. Ms. Mantis and Ms. Martell, is there anything that either of you wanted to add? Okay, then I have no further questions. Thank you very much.
Thank you very much. I think we will just go another round of questions. I think a few of us have maybe some follow-up questions. I wanted to raise one point, and that is, I'm going to quote my colleague, that you unabashedly endorsed looking this class approach. But that's not my sense. When the petition and the petitioners filed this petition, it was to ban a class of chemicals. And our staff said, we're not comfortable with that approach. And to your point, having just gone through the phthalate issue and dealing with that, they were not comfortable with looking at an entire class of chemicals. And so that's why we turned to you and the study to give us some guidance as to what's feasible and how we look at this. So I just want to be clear that, and I think we've already covered this, we're looking at some place in between chemical by chemical versus the entire class of non-polymeric organohalogen flame retardants. This subclass approach.
I would agree with that. I mean, the subclass is still a class approach, but it's not trying to deal with the large set, the 161. You would be trying to deal with one group with 10, one group with 11, those subclasses. So yes.
Okay. That's all I have right now. Commissioner Adler?
Well, I should resist, but I'm not going to. I'll just read your concluding remark. Although the challenges to a class approach might appear daunting, the alternative, individual assessments of hundreds of chemicals, is unrealistic. The only possible practical approach for a set of chemicals as large as OFRs is a class approach. But that's just a quick response. I do have one or two questions that I'd like to ask. If we were to, for those data poor sources, turn to in vitro costs, would that then add to the budget that you've laid out, the $14.5 million and the 8 years, if there were to be considerable numbers of in vitro testing?
I want to just clarify which budget you're discussing.
I'm talking about the 8.5 years and $14.5 million for further study of OFRs that was spelled out in the NAS recommendation.
on the actual report as opposed to the.
Yeah, just to clarify, that particular number was not a formal part of our report. The committee didn't do.
Sure got my attention. Yeah.
But at the request of the staff, we did, at the staff level, did do those estimates. And part of the reason that the committee didn't provide those numbers directly was just because of all of the decisions that Dr. Dorman went through that would affect those estimates, and it was just impossible to run all the scenarios. So we made some logical assumptions, things like out of the 14 classes, that 4 would have insufficient data, and that the data exists to perform the assessments on 10 of those. We then suggested one path forward would to initially do a pilot study that would let you go through all the steps for a single subclass, and then follow that up with the lessons learned from that pilot into 3 subsequent studies that would look at 3 subclasses, at a time. And so, in terms of your question about the additional in vitro work, that was not part of those cost estimates. That was additional.
That's what I thought. Yeah.
And we had a separate table that, again, gave a range of costs for animal studies and in vitro and in silico testing as well. So it would be additional.
For anybody on the panel, based on what your assessment is so far of the hazards associated, the known hazards associated with organohalogen flame retardants, is this a project worth pursuing? In other words, especially into areas where we don't have that much data, is it your sense that for somebody like us who are sitting up here as regulators, that this is something that should be examined and pursued?
So what I'll try to do is I'll draw your attention. It'll take me a moment to find where in the report I'll just draw your attention to. But for example, we tried to map the existing data for a variety of different assays that are in ToxCast and other assays. So for example, if you turn to pages 68 and 69 in the hard copy of the report that you have, what you'll see is what scientists refer to as a heat map. Okay? And so gray in the heat map means no data. Okay? Green means some level of activity. And so what you can quickly see is that within the whole group of chemicals that we're talking about, these are different biological assays that have been looked at in vitro. So using the ToxCast system, so that's the cooperative system that EPA and NTP and FDA have developed in which in vitro testing is done. So what you'll find is some of the classes have green. So what you might want to be able to do is, are there biological signals here that can help guide and inform the hazard assessment? In other cases where there's no data, coming back to ToxCast and asking, it's really critical for us to be able to do our work to have data for a variety of these different chemicals. You can again nominate the chemicals and have that data generated. That generation of data can occur fairly quickly, relatively, compared to traditional approaches. So I think having CPSC position itself so that it can use these types of data streams is actually going to be important, because you're going to encounter this type of data increasingly for not just this class of chemicals, but other chemicals.
Thank you. That's a very helpful response. And I just make another quick comment is that in terms of my task as a policy maker is I'd like to combine as much material that's scientifically justifiable in order for us to make a quick but meaningful and defensible policy judgment. So I think you've really helped us enormously, and again, I want to express my appreciation.
Thank you. Commissioner Kaye?
Nothing further. Thank you, Madam Chair.
Thank you. Commissioner Bialko?
Thank you. So let's pick up where you left off. So we have 14 classes, subclasses, right? 4 of them, you said, had insufficient data. So we really know nothing, and there's nothing to base a study on. Is that right?
Well, I'm not sure I'm not sure that's a correct characterization.
Okay, that's what I'm
that we
asking.
specifically, what I did say is certain subclasses will based on our survey, because we didn't do the deep dive
Okay.
for every single subclass, but based on the survey, there are some subclasses with very minimal data.
So in other words, what I'm hearing is start where we have some data.
So if it was, so the recommendation I think I'd give, again, as Dave, as opposed to the chair, but it's based on the work we just did.
Hard to separate those two people.
They are, but this isn't my first rodeo, so to speak. So what I would recommend is you start with the two case examples we had, because it illustrates kind of the policy questions that you're going to be faced with. And it also builds on what the committee did. So if you work with, for example, the halogenated organophosphate flame retardants, and just ask yourself, what do we do next? So we have discordant data. What will we need to do next? And what are some of our interim decisions we might want to make in order to be able to move forward? To me, that's a very logical place to start, because rather than try to look at the entire sweep of all 14 subclasses, start where there's some guidance here and work with academies or others to try to, as needed. But I think a lot of times what that'll do is very quickly, once you start to ask the questions, which of these scenarios are we comfortable with, that will provide guidance for how you deal with the other remaining 12 subclasses that you've got to work with.
That's helpful, thank you. Going back to the paucity of the traditional data versus the in vitro, you mentioned in response to some of Commissioner Feldman's questions that you run the risk of with traditional data because there's some unreliabilities, correct?
So with all data streams,
data.
they're,
Okay.
you know,
All right. So, and I think what I heard you say was, it's still valid data, but there are certain uncertainties that we have learned over time to accept, right?
there are some assumptions that we traditionally make that say, for example, traditional data collected in a rodent, we make some assumptions that that data could be predictive for human hazards.
Okay. So now we're getting to in vitro data, and is that, for lack of a better term, is that better or more measurable data?
So it will depend, again, going beyond the report, but it will depend in a lot of ways on the biology that you're trying to study.
So will in vitro, if let's say we do in vitro testing, for example, does that help us do two things? One, measure the uncertainties that we were willing to accept with the traditional stuff and let us know how well we did? Will it allow us to do that?
Well, let me kind of step
Okay,
back
thanks,
for a
'cause
second.
I'm a little confused
I'm
on
going to
the-
step back for a second. So CPSC and your staff already deal with in vitro data. And the way that you traditionally deal with in vitro data, for example, is mutagenicity data. So for example, if you're trying to make a hazard identification for a group of chemicals or individual chemical, you might rely, for example, on a traditional 2-year cancer bioassay that's been performed in multiple species. That's a traditional data. Along the way, you might also have mutagenicity data. So you know that this chemical is reactive with DNA. That's an in vitro assay. That's done in Salmonella and others. So we're already, as a scientific community and as regulators, there's already a history of using in vitro data, but it's been grounded in our understanding of the process of carcinogenicity. What I'm saying is that there's going to be in vitro data that will, as it's emerging, will also be grounded in our best understanding of the human biology or rodent biology to allow you to make informed decisions. That's an emerging field of science. It's not new. It's not absolutely new. I mean, mutagenicity, the Ames assay's been around for a long time, and we kind of feel comfortable with that one. So over time, we'll become more and more comfortable with these non-traditional data sources.
Okay, that helps. Thank you very much. I had misunderstood. Now I'm going to ask you a really tough question. You said something, I don't even know how to ask this, in response to Commissioner Feldman, where you said, not necessarily stable ray and organohalogen class. And I just wrote, I had no idea what that meant. Do you remember saying, I don't even remember the context. I was hoping that.
So I'll try to put it into context.
Okay.
So the question, my recollection of Commissioner Feldman's question is, how stable is that set of 161 chemicals?
Okay.
So in essence, if we redid the inventory survey tomorrow, might we have found 162? Or might we find 170 next year?
Understood.
So my answer is that the instability points to a future group may have identified, say, 3 or 4 more that have come into commerce in the next year or 6 months. I mean, there's no way to predict that, but it just doesn't feel like the 161 is set in stone,
Okay.
so to speak, that
That's
it's
very
actually a
helpful.
fluid group.
Okay, thank you
Okay.
very much.
Sure.
That's all I have. Thank
Sure.
you.
Thank you. Commissioner Feldman.
Just one more question, and I'll be brief. Looking through the tox studies that you've done, why would you make a decision to go zebrafish over mammalian
So we did.
versus in vitro, I guess?
Right, so for looking at developmental effects, those oftentimes require an integrated biological system. So what we want is to have a biological system in which the brain development, organ development is occurring, because it's a very, development's a very complex process. So when you think about it, we started off as a 2-cell organism, and over time very quickly become a very complex 3-dimensional organism that chemicals and other types of factors can disrupt. Okay? So the advantage of doing a zebrafish over traditional assays, there's a couple of things. One is the zebrafish, those are short-term assays. The other huge advantage that's increasingly becoming aware of in the tox community is there's a move away from using traditional vertebrate models to try to go to lower vertebrate models. So from an animal use perspective, the history of toxicology is moving away from higher organisms to lower ones.
Why?
There's a lot of pressure. There's increased costs of doing animal studies, so it's cheaper in many ways to do a zebrafish study compared to a rodent study, but there's also a lot of pressures to try to look at replacements and reduction of animal use. And that's something that's been emerging over the last couple of decades. So the zebrafish model, it also has some other real advantages in that the zebrafish model allows you very quickly to look at the morphology of the zebrafish, and we can raise, not we, but scientists doing zebrafish assays can raise large numbers of embryos very quickly. Doesn't mean it's a perfect model, doesn't mean that there aren't discordant data from the zebrafish, we illustrated that. But what we're saying is there's going to be increasing use. We don't think that's going to go away in the next 5 years. So you'll have increasing zebrafish developmental data for this class of compounds. So it may help to try to inform the hazard assessment if you think about using that type of data stream.
But ultimately, we're interested in the hazard as it presents in humans and mammalian vertebrates, not zebrafish.
Well,
Do you lose that?
ultimately, correct. I mean, ultimately, you're more concerned about the human hazard than even the hazard in mice or rats. So again, that kind of points back to mice and rats we use as surrogates for people. We've done that for decades, but we all are very familiar with the fact that there have been case examples in which human hazards were not identified in rodent models. I mean, there's some very tragic events where that can occur. So it could be that you have to look at different streams of evidence in order to be able to make that hazard assessment.
Did you want to add something?
I just want to add one thing, that that I don't want a misunderstanding with the report, in that the committee, I don't think, was saying either in vitro or animal studies. I mean, the idea is that we use all the data that's available, and we then try to integrate the data that we have. So it's not as if the committee was just advocating moving to simply doing what we called the new approach methodologies, but really trying to use all the data that's out there.
Also, I'll also add that it could be in a tiered approach.
Right.
So for example, you might find for poorly studied chemicals where you're concerned about development and effects, that you might say do a tier in zebrafish, look at how biologically active is it, and then confirm findings in a rodent model. So again, there's a variety of different ways in which those non-traditional approaches could be used.
I understand. I have no further questions. Thank you very much.
Thank you.
Thank you. I believe that all of the commissioners have completed their rounds of questioning. So hearing no further questions, I again want to thank Dr. Dorman and the entire team who is here today to present and to answer our questions, and for all of the work. And I would just want to reiterate that and emphasize the work that was done on this report, how helpful it is to the agency and to the commission offices. So my deepest appreciation for all of the work that went into it. I think you understand how extremely important it is as the commission considers how to move forward to have the kinds of resources and advice that you've given us. And I do look forward to continuing those conversations. I think Dr. Sims made some, say, movements towards that, or suggestions, but I do think that continuing those conversations would be a good thing and in the interest of the agency. So, again, my deepest appreciation to all of you. At this time, the commission is going to take a break, and we will reconvene at 1:30, at which time we'll turn to our final agenda item of the day, a briefing from CPSC staff on issues related to off-highway road vehicles. Thank you very much.